Hello, in this video I want to look at techniques of finding the volume using Washer's method. So Washer method essentially deals with a outermost radius and an innermost radius, of which when you rotate it about the x-axis you end up with this hole in the middle of the solid. So in that case, like if you were to cut a cross section of it, it would essentially look exactly like a washer that that you use with tools and things. Similarly, if you rotate about the y-axis, you generate a solid of which will have this gap, and you notice that yes, the cross section is most definitely that of a washer. Now, in any case, all that you're really doing is you're taking the difference of the two solids, and then that's what leaves the hole in the middle of it. So in that case, it becomes kind of clear that, yes, if you were to look at the Kth washer, then in any case, it's still going to be roughly the exact same thing using disk method. So that is, we know that the volume using Washer's method is the integral from a to b of f of x squared minus g of x squared and then times d of x. But this is with respect to the x-axis, okay? The other is that essentially you have that the volume, if you are integrating from, if you have a region from c to d, then it's the integral from c to d, and then you just use that it's going to be pi times a function of y minus g of y, and that's all squared, and then you just use the differential dy. But this is with respect to the y-axis. Okay, so one thing that you have to realize is that the kth kth washer. So the kth washer is perpendicular or vertical. Over here, it's perpendicular to the axis that it's rotating, but it's also horizontal. So that's just like one thing that you can kind of go with, is that you know that you have to take top minus bottom still, and then right minus the left, and so on. So let's say that we wanted to find the volume of a solid generated by the curves y equals the square root of x and y equals to x squared. Now, if we were going to, let's say for example that we want to know what the region looks like. So we go ahead and we sketch our graph. Okay, so essentially we have that the square root function looks something like that, and then the parabola looks like that. Now, we know that essentially that the region of interest, okay, we'll just do it like this since I already used it. Okay, so we know that it's rotating about the x-axis, which means that the kth rectangle or kth washer is going to be vertical. So I wanted to know like what that looks like actually, and in my mind it kind of looks something like this. So let's make this a little bit bigger and just put it right here. Okay, so here we know that the parabola is the lower function, the square root function is the top function. So we know which one is the outer radius and which one is the inner radius in this case. But as we rotate around the x-axis, notice that over here you can see that washer right there, and that you're integrating from 0 to 1 in this case. So here we just need to set up our integral. Now the integral is already set up right here in this picture, but we'll go ahead and just figure out, like, how exactly did we get that. So here we set up our volume is equal to the integral from 0 to 1 of pi. So we're going to take the square root of x squared minus, okay, so that's going to be x squared and squared, and then we'll just put dx. So this is going to be the integral from 0 to 1 of pi times x minus x to the fourth. Okay, so that looks similar. So here we'll do pi, and then we have x squared over 2 from 0 to 1, and then we have minus 1/5. I'm going to put a big parenthesis, okay? X to the fifth, and then that's from 0 to 1. And then here we'll just say that that's going to be pi times 1/2 minus 1/5, of which when we go ahead and we put this together, we end up with that this is 3 pi over 10 units cubed. This is going to be the volume of our solid. And that'll be units cubed. Now, let's say that we look at another example of which says that, what if we wanted to use the following: y equals to x over 4, and then we'll use y equals to x to the 1/3. Now, this is actually going to look something, let's see. Okay, yeah, so we'll just draw it like this. So we know that x to the 1/4 is a line, and then the cube root of x, it looks something like this. And we'll just do that. Okay. Now, let's go ahead and try to, okay, well, we'll shade the region first, right? So we know that this is the region, and for this question, I'm going to go ahead and just say that we're going to rotate this about the x-axis, or y-axis, sorry. So I'm going to rotate it about the y-axis, and in any case, I know that there's going to be an outermost function and a innermost function, or outer radius and inner radius, respectively. Now, because I know that I'm rotating with respect to the y-axis, and yeah, I tend to not label these sometimes, but it's okay. I know that I need to actually rewrite this as x equals to 4y, and then let's see, is that going to be x equals to y to the third? Okay, now that means that the volume is going to be set up in the following manner. The volume is going to be equal to the integral. Now, when you actually set these equal to each other, you can actually figure that out in terms of like where they would intersect at. And in any case, this is the point 8, 2. So this is 8, 2, and this is 0. Okay. So we're only integrating this from 0 to 2 in actuality. So we have 0 to 2, then we have pi. So that's going to be 16y squared minus y to the 6th, and that's going to be dy. Okay, because you're doing it from right to left and you're rotating, and the interval of integration is going to be from 0 to 2. Okay, so this sets up our integral very nicely. Looking at the region, we find that this is what the region actually looks like. And we can see that there's an outer circle and an inner circle, hence outer radius and inner radius. And then we see that the difference of the two produces this little washer in the middle. Okay, now in any case, let's see, all that we need to do here is just find the volume. So here we're just going to say that the volume, furthermore, is going to be pi, and then you have 16 thirds y cubed minus 1/7, and then we have y to the 7, and then this is going to be evaluated from 0 to 2. Okay, now this gives us the following. It gives us that, well, okay, let's say that we have pi, and then we have 16 thirds, and then we have, well, that's just going to be times 8, right? Minus 1/7 times 2 to the 7th, and now we just need to reduce that. So let's just use our calculator for a change. So 16 divided by 3, multiply that by 8, and then subtract 2 raised to the 7th, and that's divided by 7. Okay, and then let's see if we can just change that. Okay, so it's going to be 512 over 21 pi. And that's going to be units cubed, right? Now, what if we were to, instead of rotating with respect to the y-axis, that we did this with respect to the x-axis? Then what that would do is it would not only change the volume, but it would also change the shape that is generated. But the process would actually still be the same. So in any case, that means that your integral would be pi times x to the 1/3 squared minus x divided by 4 squared. But you can see that it looks like the following. Let's just make this a little bit bigger. So here is the actual integral that you would end up with, and there's the solid that we have. So the shape on the outside is parabolic, but the inside is actually more like a cone. And you can see that there's the washer that gets generated for the respective cross section. So it would be interesting for you to, try to figure out like what is the integral or the volume. So you know that the volume is from 0 to 2, or no, it would be from 0 to 8, and then you have pi, and then you have x to the 2/3 minus x squared over 16, and that's going to be dx. And keep in mind that that's just the area of the that washer. That represents the area of the kth washer for the subinterval from xk minus 1 to xk. If I might have said, like when I first introduced disk method, I think I said area, which is technically correct, but I just wanted to acknowledge that it's also with respect to as a disk, then you still end up with volume, and so on. So it's whatever perspective you want to take with that. The last thing that I want to point out is that notice that with respect to the volume, and you have from A to B, and then notice that you have that if you're looking at a washer method per se, and let's say that g of x is equal to 0, so this is equal to 0, then in that case that tells you that the volume is actually the area, I'm sorry, the volume is the integral from a to b of pi f of x squared dx. So what that tells you is that, we could have learned washer method first and then learn disk method, because in actuality when the bottom function is equal to 0, then it's just the original disk method. Similarly, if you look at the cross section that's horizontal, then it would be the exact same thing if the leftmost function was equal to 0. So in that sense, it tells you that with washer method, you just need to analyze the region and notice that if there is a cavity on the inside, then that means that most likely it would imply that you're using washer method, versus if there's not and the cross section is kind of like closed, then you have that it's going to be disk method instead. Now, there are other types of questions, that we will look at that will involve you using still like, washer method and whatnot. But in the next section, you're actually going to learn a method of volume that's actually much more efficient or a lot more approachable.